Hello, welcome to my presentation video on residential and similar premises. My name is Martin Lavachka, and in this video I'm going to talk about the power network, distribution panel components, protection of people, circuits, protection against overvoltage and lighting, periodic control of residential electrical installations, requirements and recommendations per type of room, and bathroom and showers. The international standard reference for electrical installation in buildings is the IEC 60364 series, low voltage electrical installations, and its European equivalent, the HD 60364. However, these standards are general, applicable to all types of premises, and do not provide simplified and ready-to-use rules for residential premises. Some of the standards from the Part 7 of the IEC 60364 address residential premises, such as the IEC 60364-7-701, requirements for special installations or locations containing a bath or shower, which provides mandatory additional safety measures for bathrooms. In practice, most countries have national regulations or standards governing the rules to be strictly observed in the design and realization of electrical installation for residential and similar premises. But these national standards are not harmonized internationally and may range from very basic requirements to advanced requirements for safety and comfort. Some of these national regulations and standards also include elements that are not covered or required by the IEC 60364 series, such as additional requirements for safety, like protection against fire risk with smoke detectors or with the mandatory installation of AFDD in bedrooms, requirements for comfort like minimal equipment per type of rooms. Finally, additional requirements are needed to cover new usages like electric vehicle charging, photovoltaic installations, etc. Therefore, the content of this section is an overview of the main requirements or recommendations for residential premises from an international point of view, based on some advanced local standards from countries like France, Italy, Germany, and Spain. But always refer to your local regulations and standards for the mandatory requirements applicable for residential or similar premises. The power network. The vast majority of power distribution utilities connect the low voltage neutral point of their MV-LV distribution transformers to earth. The protection of persons against electric shock therefore depends, in such a case, on the principle discussed in Chapter F. The measures required depend on whether the TT, TN, or IT earthing system is adapted. For fault protection, RCDs are essential for TT and IT earth installation. For TN installations, high-speed overcurrent devices or RCDs may provide fault protection of the electrical circuits. Nevertheless, to extend the protection to flexible leads beyond the fixed socket outlets and to ensure protection against fires of electrical origin, high-sensitive RCDs shall be installed. AFDDs are also recommended to extend even more protection against the fire risk. Distribution panel components. Distribution panels in residential premises usually include the meters and in some cases an incoming supply differential circuit breaker which includes an overcurrent trip. This circuit breaker is fairly accessible to the consumer. On installations that are in T-N earthing system, the supply utilities usually protect the installation simply using sealed fuse cutouts immediately upstream of the meter. The user has no access to these fuses. The incoming supply circuit breaker or main switch. The consumer is allowed to operate the circuit breaker or switch if necessary to reclose if the circuit breaker has tripped due to current consumption exceeding the authorized limit, to open it in a case of emergency, or for isolation purposes in case of maintenance in the distribution panel. For TT systems, the rated residual current of the incoming circuit breaker shall be adapted to the maximum earth impedance. For example, if the earth impedance is not more than 100 ohms, the rated residual current of the main RCBO shall not exceed 500 milliamps. In some countries, the rated residual current of the incoming circuit breaker is 300 milliamps. In this case, the earth electrode resistance shall be less than 166 ohms. In practice, the earth electrode resistance of a new installation shall be less than 80 ohms. The control and distribution board comprises a control panel for mounting the incoming supply circuit breaker and other control auxiliaries as required, a distribution panel for housing the MCBs or fuse units, installation accessories like DIN rails for mounting MCBs, fuse bases, connection accessories like COM bus bar to simplify the internet connection of devices, accessories for fixing conductors, neutral bus bar and earthing bar, and so on. Series cable ducts or conduits, surface mounted or in cable chassis embedded in the wall. To facilitate future modifications to the installation, it is recommended to keep all relevant documents, photos, diagrams, characteristics, etc., in a suitable location close to the distribution panel. The installation of SPDs at the service position of an LV installation is strongly recommended for installations that include sensitive equipment, which is very common nowadays. These devices must automatically disconnect themselves from the installation in case of failure or be protected by an MCB. In the case where the resistance to earth exceeds 80 ohms, one or several 30 milliamp RCDs should be used in place of the earth leakage protection of the incoming supply circuit breaker. Protection of people. On TT systems, the protection of persons is ensured by the following measures. protection against indirect contact hazards by RCDs of medium sensitivity at the origin of the installation. This measure is associated with a consumer-installed earth electrode to which must be connected the protective earth conductor from the exposed conductive parts of all Class 1 insulated appliances and equipment as well as those from the earthing contact of all socket outlets. When the circuit breaker at the origin of an installation has no RCD protection, the protection of persons should be ensured by double or reinforced insulation on all circuits upstream of the first RCDs. In the case where the distribution board is metallic, care shall be taken that all live parts are double insulated and wiring reliably fixed. In TN systems, fault protection is ensured by the following measures. Fault protection is ensured by the circuit breaker at the origin of the installation. This measure is associated with a consumer-installed earth electrode which must be connected to the protective earth conductor from the exposed conductive parts of all Class 1 insulated appliances and equipment. For all earthing systems, mandatory protection by 30 mA high sensitivity RCDs of socket outlet circuits and circuits supplying the bathroom. And recently, the IEC 60364 also requires the use of 30 mA RCD for lighting circuits. An incoming supply circuit breaker with an instantaneous differential relay. In this case, an insulation fault to earth could result in a shutdown of the entire installation, where a surge protective device is installed. Its operation could appear to an RCD as an earth fault, with a consequent shutdown of the installation. An incoming supply circuit breaker with type S time delayed differential relay. This circuit breaker affords protection against fault to earth, but by a short time delay provides a measure of selectivity with downstream instantaneous RCDs. Tripping of the incoming supply circuit breaker and its consequences is thereby made less probable in the event of lighting or other causes of voltage surges. The discharge of voltage surge current to earth through the surge arrestor will leave the type S circuit breaker unaffected. Incoming supply circuit breaker without differential protection. In this case, the protection of persons must be ensured by Class 2 level of insulation up to the downstream terminals of the RCDs. All outgoing circuits from the distribution board must be protected by 30 mA or 300 mA RCDs according to the type of circuit concerned. Where an SPD is installed upstream of the distribution board, it is imperative that the device automatically disconnects itself from the installation following a rare failure. Some devices employ replaceable fusing elements. The recommended method, however, is to use a circuit breaker. Circuits. National standards commonly recommend the subdivision of circuits according to the number of utilization categories in the installation concerned. At least one lighting circuit, each circuit supplying several rooms for a maximum surface of 50 meters squared. At least one socket outlet circuit rated 16 amp, each circuit supplying a reasonable number of socket outlets in series, taking into account the wiring cross-section area used, the wiring lengths, and the temperaturized effects on each connection according to the foreseeable applications used. One dedicated circuit for each high-load appliance such as washing machine, dishwasher, cooker, etc. Water heater and fixed heater units shall be connected by terminals. In this table, you can see an example of the recommended number of socket outlets and fixed lighting points according to the application and the locations in dwellings. IEC 60364 and most national standards require the implementation of protective conductors for each circuit. This practice is mandatory where equipment provided for earthing may be connected or installed and shall be seen as the general case for all circuits, including circuits supplying socket outlets. The protective conductors must connect the earthing contact in each socket outlet to the main earthing terminal at the origin of the installation. Furthermore, in some countries, 16A household socket outlets must be provided with shutters, at least in rooms where children are often present and in places where water is present. The cross-section area of conductors and the rated current of the associated protective device depends on the loads connected to the circuit, the ambient temperature, the material of construction where the cables are located, the type of installation, and the influence of neighboring circuits. Moreover, the conductors for the base, the neutral, and the protective conductors of a given circuit must have the same cross-section area up to 32A circuits. Protection against overvoltages and lighting. The three following main rules must be respected in particular. It is imperative that the three lengths of cable used for the installation of the surge arrestor each be less than 50 centimeters. For example, the live conductors connected to the isolating switch, from the isolating switch to the SPD, from the SPD to the main distribution board earth bar. The main distribution board earth bar must obviously be located in the same cabinet as the SPD. It is necessary to use an isolating switch of a type recommended by the manufacturer of the SPD. In the interest of a good continuity of supply, it is recommended that the circuit breaker be of the time delayed or selective type. Periodic control of residential electrical installations. IEC 60364 recommends periodic verification of electrical installations. Electrical risks in new residential buildings are covered by installation and product standards. However, for existing buildings, the safety levels in older buildings are often far below current standards. IEC 60364-6 recommends periodic verification of electrical installations in dwellings. For example, mandatory safety audits are an efficient means to verify if the electrical installation is in a safe condition and to inform the owner of the safety level of his home. Why are periodic verifications necessary in dwellings? Existing electrical installations may be dangerous because of installations complying with standards dating back to the year of construction and the technical requirements of standards changing over the ensuing years, aging of the electrical installation itself, including loose connections, aged insulation material, broken parts such as shutters in socket outlets, for example, or flying terminal blocks for luminaires. Change of usage of electricity due to the change in the number of inhabitants and the electrical installation was modified by the person living in the dwelling and usually not by a qualified electrician. Typical types of dangerous situation may be such as absence of protective earthing conductor in dwelling, absence of protection against electric shocks at the origin of the installation, overcurrent protected devices not adapted to the cross-section of the conductors, absence of high sensitivity residual current device in bathrooms and for circuits supplying sockets outlet up to 32 amps and in dwelling circuits for lighting. Damaged sockets outlets or socket outlets without PE conductor, incorrect use of extension cords leading to overloaded socket outlets, or damaged and outdated electrical equipment. In this table, you can see an example of recommended points to check during the periodic verification of electrical installations in dwellings. Requirements and recommendations per type of room. On this slide, you can see typical circuits and wiring devices to install in a kitchen. On this slide, you can see an example of recommendation and typical circuits and wiring devices to install in a living room. Bathrooms and shower rooms are areas of high risk because of the very low resistance of the human body when wet or immersed in water. Precautions to be taken are therefore correspondingly rigorous and the regulations are more severe than those for most other locations. The relevant international standard is IEC 60364-7-701, applicable to electrical installations in locations containing a fixed bath or shower and to the surrounding zones. Refer to country-specific standards whenever they exist. Precautions to observe are based on three aspects. The definition of zones numbered 0, 1, and 2, in which the placement of any electrical device is strictly limited or forbidden, and where permitted, the electrical and mechanical protection is prescribed. The strict adherence to the requirements prescribed for each zone, and the establishment of an equipotential bond between all exposed and extraneous metal parts in the zones concerned. Classification of zones. Subclause 701.30 of IEC 60364-7-701 defines zones 0, 1, and 2, illustrated by the following figures for most common examples. The IEC 603-64-7-701 provides the specific requirements for the different zones defined in Section 2.1 applicable to the equipment circuits, etc. It is an international standard that has been achieved as a compromise between countries, considering their existing national standards and regulations. Thus, it includes a significant number of notes providing country-specific requirements. It is thus difficult to share a simplified view of these requirements. Therefore, what you see below is an overview of the requirements for each zone based on the French standard. In this table, you can see an overview of the specific requirements for bathrooms and shower rooms based on the French standard. In this image, you can see a supplementary equipotential bonding in the bathroom. We come to the end of this presentation. Thanks for watching.